Security, Part 1. In this nugget, we talk about security. This is part 1. We start off, first of all, by talking about authentication. We just want to make sure that we only have our users logging onto computers and that the users can prove they are who they say they are by entering in a password or using some kind of a token-based authentication. That way we don't have internet strangers using our computers over the network or, interlopers just walking through the building and sitting down on their workstation and doing whatever they want to. We also want to make sure that we protect that data and we secure it. We can do that by making sure that any hardware that we discard, such as old hard drives, don't have company data on them that could be compromising in some way. And we also want to make sure that we have good backups of our data and that it's physically secure. In addition, Windows includes some great encryption technology that pretty much bulletproofs your files in terms of making them impossible for unauthorized parties to be able to see. And it's very important at times to audit who accesses what files. Now, the cornerstone for most security models is going to revolve around authentication. I want to make sure that only my administrators are doing administrative functions. I want to make sure that my generic users can do at least their basic functions. But I don't want anybody who's not even a member of my company or a trusted party to be able to do anything to any of my systems. I don't want them to log on. I don't want them to be able to sit down at a computer and mess around with the file system. I don't want them to do anything they don't have authentication to do. And we have to make sure that we do properly authenticate our users. Now, this has come a long ways in Windows operating systems. Back in the days of Windows 95, you could go to a machine and turn it on, and then you could just cancel the logon dialog box and have full access to the entire local hard drive, and you could delete files, modify files, forge files, do whatever it is that you wanted to do. Now, fortunately, with NT-based operating systems, including 2000 and XP, you do have to hit that Control-Alt-Delete thing to be able to log on with the username and a password in the corporation. And I'm mostly addressing authentication now and the rest of our security topics in this video in a corporate sense. So we're going to assume that our computers, for example, are members of a domain instead of just work group computers or home computers. Now, some will still apply to those cases, but for the most part, corporations are what we're looking at. And then one of the key things for the corporation is to make sure that you have good password management. So how do we manage those passwords? Well, as administrators, and I'm talking about from a higher level as IT department administrators or higher level help desk folks or other people in the decision-making process, we need to make these kinds of decisions. How long do we want the passwords to be? Is 7 characters enough? That's very often enough in many corporations. But if we have secrets that we're guarding, company secrets, or if we have something that's maybe a government office that's protecting something of vital interest as well, then we might want to make them longer and more complex just to begin with. And this is simply because, as a rule, the shorter and easier, or less complex, a password is, the easier it is, number one, just to guess. You might be able to walk up to a computer and someone has a picture of their kitty cat named Tabby all over their desk. So guess what I think I'm going to guess for their password? That's right, Tabby, or some variation thereof, maybe with a capital T or an or a lowercase t, or with an at sign for the A in Tabby. I can go through all different kinds of combinations, and I'll just hit the word Tabby a few times until I finally guess the right one if someone's not being careful with their passwords. But if I make it longer and more complex, then they have to get into things such as 8 characters or more. Sometimes there might even be 14 characters or more. And they have to have complexity. For example, they have to have alphanumeric, so they have to have letters and numbers. They have to have upper and lower case. And they may have to have also certain special symbols like the asterisk or ampersand or any of those other special symbols that would appear on your keyboard. So if I require those kinds of things, I significantly increase the complexity of a password, and I almost remove the ability for anyone to be able to guess the password to a point. And moreover, there are certain password cracking programs out there that, given enough time with simpler passwords and shorter passwords, can guess them within just minutes. And what it does is it usually does something called a brute force attack, and it uses a big dictionary of all kinds of passwords that it has been able to collect, or that you assign to that program. And then it just goes through the dictionary and it keeps trying each individual password until it finally gets one that matches. Well, if you make the passwords longer, 8 characters or more, and if you make them complex, that makes it very difficult for those programs to be able to do it. They might still be able to, depending on exactly the length and the level of complexity, but it might take days, weeks, or even months to be able to crack some of those passwords in that case. And then we also have the issue of expiration. How long do we want those passwords to last? I mean, if you have extremely long and complex passwords, and it would take a password cracking program, let's say 30 days to be able to crack it, then maybe we should have our passwords expire every 2 weeks just to be safe. Also, when the password expires, I don't want the person who's changing their password, my user, to just say, well, you know what, I liked my old password, so I'm just going to change it to the same password. Certainly in the interface, you can do that. But if we have history, then that would make sure that the operating system that authenticates that user can remember the last few passwords that user has chosen, and then it will say, you can't choose any password you've chosen in the last 5 tries or the last 8 tries or whatever you select there. So let's go ahead and take a look, at least in a Windows Active Directory domain environment, at how we configure those things. And you don't need to memorize that for A+ exam objectives, but just for sake of context and to give you a visual idea of it, we'll look at it briefly. Now here then, just for sake of context, I've gone to a domain controller, and I've opened up something called the Group Policy Object Editor. Every domain has something called the default domain policy, which is normally where the password configuration is stored. Again, you don't need to memorize this. This is just for sake of context. And this is then where we would configure things such as the password history and age, how long it goes before it expires, in other words, the password length, whether or not it has to meet the complexity requirements, and so forth. And then all of these settings would apply to all the computers that were within my domain and to all of my users that logged on. Then besides your password, another important component in proper authentication is to make sure that you lock the workstation. That forces anybody who walks by your workstation when you're not there to prove that they have some kind of a credential to be able to actually log on. And if they don't provide your logon credentials, then they will not be able to get into your system and be able to manipulate your files or your programs. So for example, if you can picture this, what if I just got thirsty and decided to go to the break room and get a drink? Well, if I'm logged on as something like a high-level account or a privileged account, like a domain administrator, that means that anybody who's walking by can sit down at my workstation, and they might even just try to play a joke on me or something like that. But if they're not educated in what they're doing, they could do company damage, delete user accounts and lock out the vice president from being able to log on to his computer. Or they might have malicious intent and do the same kind of thing. Or they might start my email program and send a broadcast email to the entire company about something that might embarrass me. Of which there are several things that anybody could send out. So I think you get the idea there. You make sure you lock the workstation. Now, how do you do that? You can press Control-Alt-Delete, and then there will be a button there that will say Lock the Workstation. Or what I usually do is to give myself a shortcut. Just hold down the Start button, or the Start key on the keyboard, and then press L. And that will automatically also lock your workstation, and it's fewer steps to have to take to lock it properly. And then these authentication methods go beyond passwords. These are two-factor authentication, where I have to have something I know as well as something that I possess in most of these cases. A smart card being a good example of this. I have to have a smart card, which could also double as an employee ID. I put it into my smart card reader, usually attached to a USB port on my computer, and then I have to enter in a PIN that would then unlock that smart card and release a certificate and make it able to be authenticated against a domain controller somewhere. We have a tendency to think that smart cards really just have pins in them, and that's it. But really, it's once you enter in that pin, it unlocks the smart card to expose the certificate. And using a certificate authority is typically how smart cards are done. And then there's also biometrics. This might actually be only a single-factor authentication, where you can have a retina scanner or you might have a fingerprint scanner. And this would, of course, then identify a physical characteristic of that person, and it's usually pretty irrefutable. And then as far as this fob is concerned, remember they usually have an LCD on the front of them with a number that changes every 60 seconds, and you combine that number with your PIN to enter in your passcode. Now the reason why a server somewhere knows that you've entered in the correct PIN and passcode is because it'll have record of your PIN, but it will also change internally within its own programming that same number that appears on your LCD screen. You synchronize those up. So when in 60 seconds expires, then your LCD screen changes, and the server that keeps track of all of this has also changed, and they changed to the same number. That's how they're able to keep track of things. Now, in troubleshooting all of these things, starting with the fobs, if something's not working right, the user's confident that they are entering in the correct passcode with their PIN and their number that appears on the LCD screen, and yet it still does not log the user on. Very likely, what's happened is those things can get out of sync. It doesn't happen very often, but those key fob devices are battery powered, so there could be a battery problem on it. You might need to replace that. Although many of those batteries, unless they're defective, are designed to last for years. Or it could just be something wiggy happened, and it got out of sync with the server, and so they no longer have the same number on them anymore. For that kind of a thing, you may have to bring the fob into some kind of a management workstation where a higher-level trusted administrator is able to resynchronize that fob with whatever software on the system, on the server, it is that will resynchronize it properly. And then for the biometrics, things such as fingerprint scanners, then when you scan maybe you scan your index finger and it doesn't seem to be able to read, well, that could be a problem with the physical sensor itself, so you might need to have that checked out. Or if you scan it and the physical sensor is working properly, but you're just getting denied access, then it could be that you're scanning the wrong finger. Try giving it the middle finger, see if that helps anything. Something we're probably all too eager to do when these things don't work right for us. Usually things like this that do fingerprint scanning will somehow synchronize with a user account's database. And again, that might be something like an Active Directory database somehow. And so make sure that the user's account has not become disabled or they have not locked themselves out. Maybe they have scanned the wrong finger a certain number of times. Some of this biometric software that works in conjunction with these devices, it's only allowed to accept a certain number of incorrect scans or invalid scans. And if you do anything past 3, it may lock out that user's account so that they would then have to call a help desk to get that unlocked. And then this is something that applies to all of these as well. If they use certificates, and the smart cards will, and these fobs may use a certificate as well. There's also one I haven't written on here, but it's another one that applies as well. And that's a token. Remember we saw those earlier. They can plug into a USB port. These use the token and the smart card for sure, and maybe these other two as well, depending on the manufacturer. If they use a certificate, check to see whether or not that certificate has expired. And the expiration can take place either on the device itself, or it could take place on the server itself. And if someone's neglected the certificate authority, then it may have expired. And if that would be a really big problem because nobody in the company would be able to log on at that point. So that's one of those things that administrators have to watch out for carefully. Now, there's another technology here that's increasing in its popularity and usefulness, and that's something called a virtual private network. You see, for a lot of people that don't work in the office or that are road warriors, we need to be able to connect to the network as if we were locally there in the building, in the corporation. And yet we can't because, of course, we're on the road. So how can we secure that? Because we don't want to make a connection that's unsecured and then have someone be able to eavesdrop it and pick up passwords or to intercept documents or anything else that would compromise security. So what's done there then is that we use virtual private networking. Now this has to be configured in a couple of different ways. Number one, there's going to be usually something called a RAS server, or sometimes it's called a routing and remote access server. In the NT days it was called remote access server, now it's called routing and remote access server, so it's usually called one or the other. And then we also will have here somewhere a domain controller. And this is a Windows 2000 kind of a context, but it applies to most major server operating systems. And then over here we would have our user. Now we might have a user that's a home user. And they don't actually have to go into the office very often, but they do need to make connections to our network over here where these servers are located and make sure that it's a secured connection. Then that way they can access the file server, and maybe they have a web server over here, a mail server, and so forth. We just need all those resources the same way as if we were in the office. So what happens now is we try to establish a connection. This can be through a dial-up modem. This can be also through a cable modem connection, any kind of an internet connection, whichever way you want. Doesn't really matter what the media is there or what the method is. But what we do is we establish a connection to the remote routing and remote access server, which can then authenticate us against the domain controller. The domain controller says, hey, that person is an authenticated user, and then routing and remote access will send back a message to us saying that we can go ahead and establish that connection, and it will then create a connection in a virtual private network, which is a highly encrypted tunnel where all of the data passes back and forth through it. So that even if someone on the public internet were to intercept any of my traffic, then they wouldn't be able to decipher any of it because it really is very tightly encrypted. Now, the only potential drawback to this traffic now, once we get our session established and we got this user on our network at large over here, is that none of this traffic, if it goes through an intrusion detection system like an IDS or a firewall. Sometimes they're kind of integrated and they're almost synonymous in some cases. But if any traffic going back and forth through that is going to be protected by that tunnel, and it also conceals the contents of those packets from my firewall and my IDS. So that's just something that we should be aware of. Normally an IDS, or an intrusion detection system, will be able to inspect packets and see if there's any kind of suspicious behavior or what we call malformed packets that hackers can often use. Well, now since it's going through this tunnel, then we don't really have the capability of inspecting it at this level. So just something to be aware of. Probably not an issue in many cases, but just so that you know about it. And then when it comes to securing our data, we need to be careful in the corporation about how we handle our hardware. Now, we talked a while back on decommissioning hardware, like sending it to a recycling center or something like this, or giving it to nonprofit organizations. However, I might have a user's computer. It might even be not particularly a privileged employee, not an administrator or anything like that. But nevertheless, they might work with certain documents that we wouldn't want to be available to the internet public or to anybody else out there outside of our corporation. Well, if we get this person's computer and it's kind of getting old and we need to decommission it, so we decide to give it to a nonprofit organization, even if there's somebody at that nonprofit that might have malicious intent or they might stumble accidentally across some data that was left on the hard drive, well, then we might embarrass the company with that. So when you decommission your hardware, you have to be very careful about how it's recycled and things. One thing that you could do is sometimes you just absolutely cannot send back hard drives to anybody, and this depends on the level of security requirement that you have for a department or for your corporation on the whole. If this is the case, sometimes companies will send their hard drives through extremely powerful magnets, or they'll have a wipe or erase type of a program which will entirely scramble that hard drive and make any data retrieval from it impossible. But it also trashes that hard drive many times. It's very often destructive, and you cannot recover that hard drive for any other purpose. So then you would send it to materials recycling because nobody else could really use that drive anymore. Also, be similarly precautious about anything else that you discard or that you send in for recycling, such as thumb drives. Make sure that those are totally cleared and wiped out. Other things such as tapes. This is a big issue because a lot of corporations will go through quite a few tapes, and those tapes have a limited lifespan. Sometimes they get kind of stretched, sometimes they get damaged, sometimes they get tangled. It might even gotten caught in the rollers somehow, and so you have a big mess on your hands. Well, when you discard it, somebody who's got some determination could still stream through that tape and potentially retrieve some damaging information off of it. So you got to be careful about things like those tapes as well. For those, what we normally do is something called degaussing, and this is where you'll if I can spell it. And this is normally where you'll take something degaussing, and you'll take a big magnet and you'll send that tape through it. And of course, the tape is got magnetic material on it, and the magnetism there will then destroy any possible retrieval from that tape. Likewise, be careful when you do any kind of data migration. Maybe you're just replacing the hard drive in a user's computer because now hard drives are larger and cheaper, but their existing hard drive, maybe it's only good for 20 gigabytes. Well, they use more data than that, so you decide to replace it. What do you do with that old hard drive? Even if you put it in another computer in a different department, it might be in a department that doesn't have the security clearance to be able to read any of the data off of that drive with permission. They're not supposed to be able to read any of that data. So you want to make sure that you don't reallocate hardware to different locations with sensitive information still on it. Likewise, if you were to do something like back it up instead and then restore that data onto a new drive, you don't want to also leave that backup data where anybody can get it either. Now, when it does come to backing up, we do have one important thing that we need to make sure we address. Remember I talked earlier up here about you might get a tape that gets caught in the rollers and a big mess is made. This is really just a huge disaster. One of the things that causes that to happen in the first place is dirty heads. So you need to make sure that you periodically clean the heads and capstans and rollers on your tape drives, because in minuscule amounts the material off of those tapes will roll off of that tape material, and it will then eventually make its way onto the capstans, the rollers, and the heads. Well, if you clean the heads, then that's going to make sure that you can get good read and write off of that tape. And by cleaning the capstans and rollers, you can make sure that the tape doesn't get jammed in there or get stuck to a roller and create a mess. and check with the manufacturer to see what the cleaning requirements are. There may also be an additional kind of a cartridge that is a cleaning cartridge, and you just run that cartridge through the tape drive and it will clean it automatically. Or you might use a cotton swab and isopropyl alcohol or some other kind of alcohol, depending on the manufacturer's requirements. And then when you create a backup, make sure you password protect it. Most backup utilities, including the NT backup utility that's included with Windows 2000 and XP, does allow you to assign a password to that backup tape or whatever the backup is. So make sure that you do assign a password. And third-party products will also give you some kind of a password protection. Although third-party products usually for the corporation is preferred by corporations instead of NT backup because it gives you more options and more flexibility, and it also gives you additional levels of security and tighter password protection than just the one that comes out of the box with 2000 and XP does. And then also, once you make your backup, make sure you physically secure that backup. Because there is some chance that even if you password protect it, if someone has enough time with that tape where they were to steal it, then they might someday be able to crack the password or get through it somehow. So we don't want to open up any avenues of opportunity. That's why when you create a tape backup, you keep it in a secure location. Now, in a lot of larger corporations and universities and things, they have these big robotic machines that change the tapes for them automatically and put them in a storage location automatically as well. And they're in highly secured rooms with only secured access. You might have to have something like a specific security card or something to be able to get in there. But especially if you're in one of those locations where it's a smaller to medium-sized company or somebody that doesn't have a robotic library that's automatically going to secure the location of those tapes, then you're probably going to have somebody using SneakerNet to move those tapes back and forth. That means, yeah, they're using their sneakers to walk back and forth between the server room and some cabinet somewhere. Or maybe it goes into somebody's desk drawer or into somebody's locked cabinet in their office. Now, those are all locations that could reasonably be secured to some degree, but they're not really that secure because someone with a little determination can always open up or pry open one of those cabinets. So we really have to be careful about physically securing the tapes. In some locations, they're as secure as the server room, and there might be a dedicated room for things like backup and media that you have to have, again, key card access to or some other kind of restricted access to. And then the other thing you want to do is, usually we keep a set of tapes on site and we physically secure those, but we also will have a set of tapes, an exact copy of those tapes, off site as well. Now you might only do that maybe once a month or something like this, or you might just take your older data and send it off-site for archival purposes. But the purpose of off-site is so that if I have a physical disaster in my existing server room, the sprinklers come on, or a fire comes in, or the building gets flooded due to natural disaster, anything like that happens, well, if I lose all of my servers and I lose all of my tape backups that were in that same server room, I have nothing. I've just pretty much lost the company. So what I want to do is usually you can hire companies, hire off-site storage companies that will have environmentally controlled locations where they keep it cool and low humidity or a reasonable degree of humidity, and you keep those tapes then off-site. Then if a natural disaster occurs, you can rebuild the company using those tapes that have been stored off-site. Now this also ties back into the physical security here as well for two reasons. Number one, wherever you store them off-site, thoroughly check them out and make sure that they can physically secure your tapes from any intruders. And they also have to guarantee that when someone comes in to check out a tape, that they thoroughly confirm the identity of that person. And there may be multiple methods for doing that, so just make sure that they're secured. And then also in terms of physically securing it, there have been a lot of cases in recent years where somebody, an IT professional usually, has taken something like a spare hard drive or a backup hard drive or a tape backup somewhere else to an off-site location or to some other office, and in the meantime their car gets stolen while they went into the 7-Eleven to get themselves a big gulp. Well, guess what? Now that data could be in the wrong hands. Very often it's in the hands of somebody who wouldn't know what to do with it in the first place. Nevertheless, we're in a very unenviable situation in that case where we have lost data, and because we don't know what could have happened to it, we have to assume the worst. Next then, encryption. Encryption technologies are used in a lot of different places. So for example, when we log on to a server, we don't want our password to be transmitted in the clear across the network for someone to be able to potentially intercept and find out what my password is. So there's an encryption that takes place with that. Really, it's something called hash algorithms that take place. But regardless, what it does is it turns your password into gobbledygook so that even if someone were to interpret, or rather to intercept some of that logon authentication information as it goes across across the network, they won't be able to make any sense out of it. Encryption is used in other places as well. It's used in the virtual private networks that I just told you about. It's also used in remote desktop and remote assistance. So we see it all over the place. One of my favorite places where we use encryption technologies involves something called certificates, and that's what Microsoft uses in their encrypting file system. And this is an excellent way to protect documents that you might consider confidential or private. So for example, here, the trainer, and I've logged on as the trainer right here, has gone to this computer and they're just doing some normal administration, for example, and they wanted to go to this backup drive. And notice that somebody else normally logs onto this computer and has created a folder. Well, the administrator, maybe they're human just like everybody else, they say, wait a minute, we got our backup data here, but I wonder what this guy, what in the world is he creating here in these documents? My plan for world domination. My plan for world domination. Let's see what he's got in mind here to take over the world. And if you pause the screen for a moment and look at that, you'll probably see that. Alan apparently is not the first one to think of this kind of an idea. But anyway, he has this idea for world domination. And then maybe later on in the break room, I tease him about his ridiculous plan. So as we take a look at that, though, Alan gets his feelings hurt, and he says, you know what, I'm sick and tired of people looking at my documents. Those doggone administrators and people like that, they just think they own me or something. So this guy wants to get rid of any ability for other people to be able to read his documents. Well, he can use the encrypting file system to a point to make sure that nobody else can read it. Now, any other generic user will not be able to read that data. Technically, someone who has the proper capabilities would be able to read it even if they're not the original user who encrypted it. But for the time being, let's just take a look at how we can protect that document from prying eyes. So Alan Smithy has learned something about, and that's his name here, I've logged on as Alan Smithy. He's learned something about file encryption. He read it off the internet or something. So he says, I think I can encrypt that document that I was trying to protect. So I go to my documents right here, and there's my plan for world domination. I'll right-click on it and choose properties. Now, what's that encryption? Is it read-only? No, because they can still read it. It's just that it's not encrypted if I just do that. I wonder what this advanced thing is. Oh, there it is. Look, encrypt contents to secure data. Clicks OK. Clicks OK. And I want to encrypt the file and the parent folder. Yeah, I guess I can do that. By the way, just so you know, when you do this, it doesn't technically encrypt the parent folder. It just puts a flag on it that tells it to encrypt any of the contents of the folder. You can only encrypt actual files. But regardless, I'll go ahead and click OK here. And then now, hey, look, it also changed color. Look how it's green now. That's the case with the encrypting file system documents. Anything that has been encrypted will now appear in green. Now, for Alan, who has encrypted this document, there's actually a sophisticated set of encryption that has taken place here. There's two things that have taken place. One is that there's a file encryption key, which is really not that sophisticated by itself, but it's further encrypted using certificates. And so because of that, it's very difficult to gain access to the file encryption key. It's like locking a key inside of a safe deposit box. You can't get to the key. So that's what this is about. And we'll just go ahead and double click on this, and we can see here that Alan can open up and read this document just the same way that he could before. He will very likely see no difference at all in how he accesses this document. However, now here, the trainer account logs on again, and he says, you know what, I'm going to go back in and look at that document. I'm going to print it out and send out that that document of Alan's to the whole office to show what an idiot this guy is. So we'll open up his plan for world domination, and as you double-click on... Wait a minute. Denied? That can't be right. I opened it up just yesterday. What's going on here? Try it again. I'm denied. That's not right. What's going on with this thing? Oh, you look at the green color of that. Hey, I'm technical enough to know that this is encrypted. So I'll right-click on it, choose Properties, go to Advanced, and I'll clear this checkbox, right? I'll click OK, and OK again. No. You cannot do it. Access is denied. So just in case you were wondering if someone could decrypt it, they can't, because they still have to have the file encryption key in order to decrypt this document, and that cannot be done without the original user's certificate. I have no access to that original user's certificate to be able to use it. Therefore, I'm unable to do that. Now, just so that you're aware of what goes on with this, in order to make this work, we have to have a couple of things in place, and that usually takes place in the default domain policy. I'm going to right-click on that to edit this, and when we go into Windows settings, security settings, and then we go down here to public key policies, then there's the encrypting file system that I've selected right here. Now, this is more information than you need to know for A+ exam objectives, but once again, I'm going to give you the sense of context here. By default, with Windows 2000 domains, or rather Windows Server 2003 domains, there is nothing here. This is empty. This whole thing is empty. I manually placed this James certificate here. Without this James certificate, then Alan Smithy would be the only person that could encrypt and decrypt that document. And if Alan Smithy's account became corrupt or something and his certificate got lost or damaged, then that document would be permanently encrypted, and neither Alan Smithy nor anybody else, even a domain admin, could ever recover that document. It would be cryptographically impossible to recover that data. That could be very damaging if it was actually a useful document and it had our company financials in it or something like that. And if we lost that, then we could be through as a business. So what we do is we right-click in here and we create a data recovery agent, and that's what I did here. And I created this user named James as the data recovery agent. And you can see here that they have a certificate that gives them the ability to work with other users' documents. So I'm going to go ahead and log this user off by logging off, and then I'm going to go ahead and go back to that user's document, document, Alan Smithy's document. And as the user of James, then I'm going to go ahead and see if I can open it up. By the way, I have to log on as James in order to gain access to my own certificate. When you log on, it gives you access to your own certificate, and it's placed in your local profile. And then once it's there, I can use it for whatever its intended purpose is. Now, the only problem with that is my own personal certificate, even as James, is only useful for encrypting my own documents. To decrypt somebody else's documents, I have to export my certificate from the policy that you saw earlier, and I then have to import it over here. I've already done that kind of in the background and offline here, because our point is not how to export and import certificates. But I have done that. Now I have the certificate that belongs to the data recovery agent here. Now then, when I go to Alan's documents, can I look at his plan for world domination and hopefully even steal his plan and call it my own? I double click on the document. Yes, indeed I can. I just invented Starbucks, apparently. So now I've got the ability to be able to decrypt this user's documents. And if I realize, this is a document that should be available to the entire world so that everybody can see it, I can even right-click on it, choose Properties, go to Advanced, and I can decrypt this document so that he no longer makes it hidden from everybody else. Now, in our last video, we talked a little bit about auditing, and I'm going to get into a little bit more detail here in how to do that. Now, this what I'm about to show you is not something you need to memorize for the A+ exam objectives. Just know in principle that you can audit certain kinds of things, and here I've gone to my domain controller, where I've gone into something called group policy management. Now, if I haven't mentioned this before, group policy is how you control virtually every aspect of what the user can and cannot do in the domain. In this case, I'm going to go to the default domain policy where I've already opened up a specific policy for it, and I've decided to go in here and I want to audit object access. So if I want to see if somebody is able to successfully or not successfully access a given file, maybe I want to see who's trying to access our financials or access sensitive documents that might have a secret company data in them, then I want to know who does it and when. Well, I can double click on this and I can define the policy settings to see when they are successful or when they fail. And it's not just those who are successful that I want to log. I also want to see who keeps trying to get in there and doesn't have permission to, and that's probably why they're getting failures. I also want to see when someone logs on, for example, see if they're having trouble with their passwords, or see if there's a brute force attack, perhaps, against one of my user accounts. And if that's the case, then that's what happens when someone is sitting down at a console somewhere and keeps trying to log on as that user, and they keep guessing the password over and over again and keep trying a different one each time. And that can be either a human that does it or it can be a program that does it automatically. Well, if I get 1,000 failed logon attempts, then I know that there's a problem with someone trying to break into one of our accounts. Now, then the next thing we need to do in terms of auditing is to actually go to the file or folder that we want to audit, because not everything will be automatically audited. Let's go back to this guy's documents, Alan's documents, and we've already decrypted this. It doesn't matter if it's encrypted or decrypted. We can still configure it for auditing. So I can right-click on it and choose its properties, go to Security, and then on the Advanced button down here, go to Auditing, and then click on Add. And I want to know anytime anyone or everyone, I'll just put authenticated users. Authenticated users would include any user that logs on with username and password and is authenticated by our domain. And I want to know anytime they even How about anytime they even just read the file or folder or fail to? That should be enough to give us a little bit of data to look at there. So I'll click OK and OK and OK, and I'll close that up. Now what I'll go ahead and do is access it. Actually, because I could have left that all open. I'll go ahead and open this now, and then just open up the document. Doesn't matter if I do anything with it or change it or anything. The fact is that I've now read it, so it should be registered in the security event log. And then now just to save time, I've skipped ahead here to computer management, where under system tools and event viewer, I've gone to the security event log. And now when I double click on this particular event, I see that someone did indeed access Alan's plan for world domination here. And that tells me who the user was. It was the trainer who was the user. I know exactly when they accessed it, and I know that they were successful in accessing that document. So this is kind of very handy in identifying who accesses what and when. In this nugget, we talked about security, and this was part one where we started off with the discussion of authentication. We just want to make sure that our users enter in the correct username and password, and that the password is not too easy to guess. We need to make it reasonably complex. Of course, the more complex and more difficult you make things, the less the users like it. But there's kind of an inverse relationship. The more secure something is, usually the more difficult it is as well, unfortunately. But those are still important things to make sure that we get right. If it gets too hard to remember those complex passwords, you can also possibly use smart cards if your company supports it. And that way you only have to memorize a brief PIN instead, but you do have to keep that smart card around. And then, of course, the securing data is very important as well. We need to make sure that when we discard hard drives or used tape backups, that way they don't contain any sensitive information. We can degauss or destroy that data. And then we also want to make sure that any backups we do create, we physically protect them and don't allow them to get into the wrong hands. We can also use Microsoft's own encryption mechanism, which is extremely tight, and we can use auditing, as we saw as well. And this is an excellent way to identify who's tried to access various resources. Well, I hope this has been informative for you, and I'd like to thank you for viewing.